All right, so 7-4 is very straightforward in the idea that, when it comes to fractions, you have to make sure the denominator is the same. So, for example, back in elementary school, if you were given 1/2 plus 1/2, we knew to add up our numerators, 1 plus 1, and we would just combine our denominators because these are like things. Like this is 1/2 plus another half. It's not like a half plus a third. Those are two different units, if you will. So this gives us 1 plus 1, which is 2, over 2, another fraction. And then if you can simplify it, you should. And in this case, you can. But what happened when you had something like 1/2 and 1/3? Well, for this one, you had to find the LCM, the least common multiple. And you would have to rewrite your fractions with the LCM. And once you did that, you could add up your fractions. So for example, the LCM of 2 and 3 would be 6. And so we would have to multiply our 1/2 so that the denominator is 6. So we would have to multiply the bottom by 3. And whatever you do to the top, whatever you do to the bottom, you do to the top. Same thing with the 1/3. We can multiply the 1/3 by a 2. And again, what you do to the bottom, you do to the top. And we can then rewrite this as 3, because 1 times 3 is 3, 2 times 3 is 6. That becomes 3/6. And then 2 times 1 is 2. 2 times 3 is 6. And now we have 3/6 plus 2/6, which now they have the same denominator. So I can combine the top and the bottom. And 3 plus 2 is 5 over 6. And we cannot reduce it, so this is our final answer. So this is what we learned back in elementary. And even though we are now being introduced to algebra concepts, the idea behind this is still the same. So the first couple problems are very straightforward in that our denominators are already the same. That's how it is on your homework as well. So because the denominators are the same, we don't have to do anything. We can just go right ahead and combine our denominator and our numerator. So this will say 3 plus 5 over 2x. And of course, 3 plus 5 is going to give us 8 over 2x. And then because these two items are divisible by 2, we can go ahead and reduce them. So it would be technically 4 over 1. But you don't have to write the 1, so it'd be 4 over x. And this would be our final answer. We wouldn't have to do anything else after this. When it comes to subtraction, though, I do like to change it to addition and then all the signs thereafter. So our minus sign will become a plus, and then all the signs afterwards are going to flip. And this is just to make our lives just a little bit easier, because if not, we would have to do the distributive property with a -1, and it gets a little crazy. So we're just going to flip it at the beginning and treat it like addition. So again, we're going to combine our denominator, which is 9b plus 45, and then it'll be 2b minus 2, that's the first fraction, plus -b plus 2. And then after that, I can combine any like terms that I have. I have a 5b plus a -1b, which is going to give me 4b. And then I have -2 plus 2, which is just 0, so I can just not write that. So my one of my answers would be 4b over 9b plus 45. And then I have to ask myself, can I simplify this, or can I factor anything out? And in reality, I can actually factor out the denominator here, and both the 9 and the 45 are divisible by 9. So I'm going to rewrite it with its factored number. And the purpose of doing this is just to see if I can eventually cancel something out. So if I look, I have a 4 and a 9, a b, and a b plus 5. There is no exactly the same factor, so I know that this is going to be my final answer, and I don't have anything else to do. So again, when you're doing fractions, when it's the same denominator, it's not a huge issue. So what do you do if you have different denominators? Well, what you can do, and these are these examples, the notes should be on Plus Portals for you guys, but these are the examples that we have in our little note section on the notes for this section. And what I like to do is create a list, things that I know that I'm going to need in order to make these denominators the same. So first things first, I need to make sure everything's written in factored form. My 9x squared, that is good to go. But my 3x squared plus 3x, I can actually factor out a GCF here. The GCF is 3x, leaving me with an x plus 1. And I'll cross it out so I know that I factored it. So I see that if I were to make my list of what to make it the same, or the LCM, I know that I'm going to need a 9, or better yet, a 3 times 3. I'm going to need an x squared, and I'm going to need an x plus 1. And so just to show you where I got those things from, I got the 3 times 3 from the 9, and I have one of the 3's already, so, I'll do that in a second. I have my x squared, and I have one x here. That's how I got the x squared there. And I could have, written it as x and x like I did the 3 and 3, but it'll be okay. The other thing that I need is my x plus 1, x plus 1. So now I can see from the first fraction, I've had everything circled. I've considered everything, if you will. And then from the second fraction, I've, again, considered everything without trying to repeat stuff. So now that that's all done, I can go ahead and start manipulating it or multiplying things on the bottom and the top so that I end up with the same answer, or I end up with the LCM. So again, I have a 9 in my first fraction, but I only have a 3 in the second one. So I'm going to multiply the second fraction by 3, because 3 times 3 will be 9. What I do to the bottom, I do to the top. Again, my first fraction has an x squared. I only have one x in my second fraction, so I'll multiply this side again by an x. And then that covers everything with this, 9x squared, and now I have a 9x squared over here. I'll multiply in a second. Now I can go to the second fraction. I have an x plus 1 here, and I don't have that in my first fraction, so I'm going to multiply this by x plus 1. What I do to the bottom, I do to the top. There's a button right there, so it kept changing the screen on me. All right, now that I've done that, I'm going to put a little line in between this so that I know that these are separate. I know that my denominator, or my LCM, is going to be 3 times 3, which is 9, x squared, times x plus 1. So I know that's what my LCM is going to be, and I can double check that everything that happens for each fraction. I'll end up with a 7, x plus 1 in the numerator, 9x squared times x plus 1. All right, that's my first fraction. My second fraction is going to say 3x times x, and I'll change that to 3x squared in a second. And then I can go ahead and multiply these. 3 times 3 is 9. X times x is x squared. And then I have that x plus 1. And so now I can just double check. Are these two denominators the same? Well, they are. So I know that I did this correctly. And now I can combine my denominators, 9x squared, x plus 1. And I can rewrite my numerator. I can put everything together right now, but I'm actually going to go ahead and do some multiplication and distributive property here. This will give me 7x plus 7 plus, again, 3x squared. This is not in standard form, so I'm going to go ahead and rearrange it so it is. Standard form is, again, when your polynomial is written from the largest exponent to the smallest exponent. So my numerator should say 3x squared plus 7x plus 7 over 9x squared x plus 1. Now, again, you're supposed to make sure you can factor everything. So I have a trinomial in the top, but it's one of those where a does not equal 1. So let's just quickly do slide and divide here really fast to see, can I, in fact, factor it? All right, so I bring over the 3, slide it over to the end, and I multiply it. X squared plus 7x, 3 times 7 is 21. And then I have to ask myself, what are the factors of 21? Well, there's 1 and 21. 3 and 7, and that's it. And then I have to look for what combines to get me my 7. Well, none of them actually give me my 7. So this actually is unfactorable, meaning that this is my final answer. Okay, I can't simplify anything. I can't factor anything out. It is completely worked out, and so it is my final answer. So this one was a little bit more complicated, I feel like. The next one's a little bit more straightforward. Again, I have a minus sign, so first things first, I'm going to change it to a plus, and then I'm going to flip all the signs in the second half. All right, I've done that. I need to make sure everything's factored. My first fraction is 2x minus 2. I'm going to rewrite that as 2 times x minus 1. Cross it out so that I'll look at that again. Then I have a trinomial, and it looks like it is factorable. I should have the same signs, and they should both be minus signs. And I should end up with a 3 and a 1. Negative 3 times negative 1 gives me positive 3. That works out. And then negative 3 plus a negative 1 is also a negative 4. So I did do that correctly. Now I'm going to make my list. Okay, in my first fraction, I have a 2. So I know I need a 2 in both of them. And I have an x minus 1. Okay, then in my second fraction, I have an x minus 3. Okay, that's not on my list yet, so let me add that. And then x minus 1. Well, I already have it in the list, so I'm not going to rewrite it. The only reason I have 2 3s over here is because I was taking the 9 and I was breaking it apart so I could see each piece. So that's why we ended up with 2 3s on the other list, but not 2 x minus 1s, because I don't have x minus 1 in one fraction, or 2 in one fraction. I only have 1 in a fraction. So now that I have my list, I can go ahead and make sure that each fraction has the same in each. So in my first fraction, I have the 2 already, and I have the x minus 1, but I'm missing that x minus 3, so I'll add it to the bottom and to the top. Okay, now it has all 3 pieces, and then I'm going to do the same thing with my second fraction. I have the x minus 3, I have the x minus 1, oops, and I am missing the 2, so I'm going to add the 2 to the top and to the bottom. Now everything should be the same, and I can just double check to make sure I have that. I'll have x minus 3 times x plus 2. Put a line here so that we know that we're not going to cross that. X minus 3, x plus 2 over 2 times x minus 1 times x minus 3. And then we have our plus sign, 2 times 2x plus 1 over 2 times x minus 1, x minus 3. All right, now my denominators are the same, so I can combine them. 2x minus 1, 2x minus 3. Well, this first little bit is 2 binomials, so I can actually FOIL that out. I'll get x squared minus 3x plus 2x, and then negative 3 times positive 2 is a negative 6. And I have distributive property here, so I'll put a plus. 2 times 2x is 4x, 2 times 1 is 2. And now I can add some like terms. I have x squared has no like terms, so I'll just carry that down. I have negative 3x plus 2x, that is a negative 1x. Negative 1x plus a 4x is a positive 3x. So now that I'm done with those, I'll cross them out. And finally, I have negative 6 plus 2. That'll give me a negative 4. Again, all of that over 2 times x minus 1, x minus 3. All right, I have a trinomial, and just like I was over here, I was at this point, and I had to ask myself, well, what is, or really I wasn't there, I was here, but I had to ask myself, can I factor this trinomial? And so that's what I did the work down here for. And so now I have to do the same thing with this trinomial. Can I factor it? And this time I can. I'll end up with x plus 4, x minus 1 over 2 times x minus 1, x minus 3. And from doing all this factoring, I can now see x minus 1 are the same, and I can cross them out because I'm multiplying. So my numerator is going to be left with x plus 4 over 2 times x minus 3, and this is my final answer. So this one is a little bit more work, but your goal is to factor your denominator so you can see everything, and then make your denominators the same. So that was make everything the same, like what we did here. Multiply anything, whether it be foiling or distributive property, right here. Make sure you combine your like terms like we did in this step. And then once you're done, make sure you factor again, because once you factor, you can see when things are the same and you can cross them out. And then finally, you'll be left with your final answer. So those are the steps every single time. You factor, see what you're missing, multiply it to make things the same, multiply and combine any like terms, and then factor one more time and leave your answer in factored form. So even though I have this 2 times x minus 3 right here, I'm not going to multiply that throughout. I just want to leave it factored. And part of this is so that I can, if I were to show anybody, I could prove to them that this was in simplest form, because they wouldn't have to factor and like double check everything. They could just look at it and go, oh, it's factored, therefore I don't see anything that's the same, so it must be in simplest form. All right, so that is the steps every time, and we did a lot more examples in class just so that we could feel comfortable with it. But making the list is probably the easiest way to do this so that you can sort of see it. They do have some problems in the textbook that sort of go over the LCM if you still want to see some examples for that. And I think I also posted a video on portals for you as well. The last problem I want to do is about complex fractions, and this is only for honors. So if you're not honors, you can stop here right now, okay? You can pause the video and you can be done with it. But if you're honors, we get to do these problems. Complex fractions, everybody's favorite. So for this one, you have to make sure that you have one fraction on top and one fraction on the bottom. Right now, you have 2 and 2. So to deal with that, we are going to combine our fractions. Just the fraction on top of the fraction, I should say. So let's deal with the first one first. I have it over 3 and the other one is over 6. So I'm going to multiply the bottom and the top by 2. And that'll give me x minus 2x. And now, because my denominator is 6, I can just put it over 6. Over, okay, I make this really thick. Over, same thing is going to happen down here. Okay, I have a 5 and a 10. I can multiply the 5 by 2 to get a 10. And what I do to the bottom, I do to the top. So now it's going to say 2x minus 7 over 10. And since it's a fraction over a fraction, okay, I'm going to rewrite this just a little bit to make my life easier. X minus 2x over 6 divided by 2x minus 7 over 10. And now it's very similar to 7-3 where we were multiplying and dividing. And for this one, you have to go to KFC, which is keep, change, and flip so we can solve it. All right, I need to make sure I can factor some things out. Or actually, I'm not going to. I'm just going to multiply across. When you multiply across, make sure you do the distributive property here. So you'll end up with 10x minus 20x. And I'm going to combine that in a second. And again, I have distributive property here. 12x minus 42. All right, once you do that, we can combine any like terms, like our numerator. We have 10 minus 10x minus 20x, which is going to be negative 10x, over 12x minus 42. And I can keep going. I can keep factoring just a little bit to make my life easier. The top is, well, sort of done for me, negative 10x. But the denominator, I can factor out as 6, and I'll get a 2x minus 7. Okay? And now that I'm done with that, I can keep it, or this will be my answer. Negative 10x over 6 times 2x minus 7. And notice I can't cancel anything out because nothing's the same. But what I can do is actually, this is not my answer. What I can do is I can reduce this negative 10 and this 6 right here. So I'm going to go ahead and do that. That'll give me a, it'll both divisible by 2. It'll give me negative 5x over 3 times 2x minus 7. And then this becomes my final answer. All right, so the next one is still the same thing. We're going to have to make sure our denominators are the same, or we should have one fraction each on top and on bottom. The numerator is done for us, but the denominator, not so much. So if I were to make my list, okay, just of the denominator, because the numerator is done, my denominator, I see in the first fraction an x minus 3, and in the second fraction an x plus 5. So I know that my fraction should say both of these for this portion alone. I'm not looking at the numerator. So if I were to multiply each side, the first fraction would be x plus 5. What you do to the bottom, you do to the top, and I'm going to write over it a little bit. So it'll look a little sloppy, but you'll be fine. And then for the second fraction, it would be x minus 3, x minus 3. Okay? So now, again, I'm just working with that denominator, and I'm going to go ahead and write it across, like how I did over here. 3 over x plus 5 divided by, and now I'm going to show my multiplication here, 2 times x plus 5 plus 1 times x minus 3. I know that's a little redundant, but it'll be fine. And because we now have the same denominator, we can combine that, x plus 5 over x minus 3. Okay, before I keep, change, flip, I'm going to go ahead and do some distributive property here and add some like terms. That'll give me 2x plus 10 plus x minus 3. Let's combine our like terms to get 3x plus 7. Again, all of that is over x plus 5 times x minus 3 divided by 3 over x plus 5. All right, now I can do my keep, change, flip. Keep the first one, change the sign, and then flip. X minus 3 over 3x plus 7. And now I can easily see that I do have something that's the same. I have x plus 5, and I can rewrite this as 3 times x minus 3 over 3x plus 7. I could distribute this, but I want to keep everything in its factored form. So this is my final answer. And I do want to talk about this right here. Please understand that, yes, these are the same, and under normal circumstances, we could cross them out. The only issue is that this is not multiplication. This is addition right here. Yes, there is multiplication between the 3 and the x, but in order to be able to cancel out the 3's, it would have to say something like 3 with parenthesis x plus 7. This shows that there's multiplication happening between the 3 and the x plus 7, and that is when we can cross things out that are the same. But because it does not show that, we don't have the parentheses there, this is not a 3, but a 3x. Okay, and you can sort of think about it as in like terms. These are not like terms, so we can't like cross them out or anything. The plus sign really puts a damper on stuff. So this is our final answer. And that is it. I hope this helped you, and I look forward to seeing your homework tomorrow morning.